Hello TaleForges, in this video I want to show you platform's movement with some nice additions, namely Gizmos and Handles. So let's dive in and see how to implement this. As you can see, I created 3 files for myself beforehand: PlatformMovementComponentData, PlatformMovementAuthoring, and PlatformMovementSystem. I also prepared a simple base to extend, so you can pause and rewrite as you follow along. We are going to approach the problem as follows. We are going to add our platform movement component data to the entity we want to move, which will allow us from within the system to run a query, go through all the entities of interest in the parallel job, and perform the movement. So let's create 4 variables to implement the logic: public float 3 initial position, public float 3 movement vector, so distance from the initial position, public float movement speed, which is specified in unit per second, public bool is reverse movement, which determines sign of the movement vector. It's time to implement player movement authoring. So let's begin with 2 serialized fields, one for the movement vector and the other for movement speed. Of course, prepare the getters. Then, inside the bake method, let's cache entity with transfer usage flag.none and add new component, PlatformMovementComponentData. Set initial position to the movement authoring.transfer.position, movement vector and movement speed from the getters, and is reverse movement to false. Normally we would move on, but in this video I also want to show you how OnDrawGizmos and Handles work in practice. There are 2 Unity methods: OnDrawGizmos, which draws objects in the scene view all the time, and OnDrawGizmosSelected, when an object is selected in the hierarchy. We are interested in the first one. Let's add using Unity Editor with if Unity Editor preprocessor directive, because we don't want to have any problems when we build the application, and this is supposed to be just a helpful tool for level design. Let's also create an OnDrawGizmos method, again with if Unity Editor. We want to draw the movement outline of our object, so we need a color. Let's set it to 0.4, 0.4, 0.9. Next, we need to cache the initial position with transfer.position and set a start and end point, it as initial position plus or minus movement vector. With all this in place, we can use the Handles library to draw a Bezier curve of the specified width. The reason I use Handles to draw a straight line is that there is no direct line thickness change in Gizmos.drawLine, which is quite annoying. I also want to add wire platform shape, so I call getComponentPhysicsShapeAuthering to get the size. Add required component PhysicsShapeAuthering. Then platform size equals shape.getBoxProperties.size multiplied by transfer.localScale. Now I want to draw the wire cube, but for that I need to change the color to the visualization color. So let's write cache color equals handles.color, then handles.color equals visualization color. Next, we draw our figure at the start and end points with the given platform size. And we restore the color to the cached value. Great, time to implement PlatformMovementSystem. In onUpdate, we need the delta time, which we get from system API time.deltaTime. Now it's time to prepare the player movement job. Let's add 2 input parameters, ECB parallel writer and delta time. Also in the execute method we'll need int sort key with the chunk index in query attribute. an entity whose components we will modify, ref local transform to get and set the position, and ref PlatformMovementComponentData, where we will toggle the isReverseMovement state. Let's cache three variables in the method implementation: initial position, movement vector, and movement speed. This will tidy up the rest of our code. Next, we need to determine the direction. This is a simple task. Just check for is reverse movement, and if yes, set -1, and if no, set 1. The target position is the initial position plus direction multiplied by the movement vector. Then let's prepare movement step. This is the direction of the movement multiplied by normalized movement vector. It as the normalized distance to move multiplied by movement speed and delta time. This allows us to save new position as the old position and add movement step. Next, if the movement is reversed, let's check with the mat.all function whether all bool free values obtained after checking the condition new position less equal target position are true. If so, we get the true state. Similarly, in the other direction, we just change the sign. As a result, we can write if should reverse movement, and pass the three necessary parameters: sort key, entity, and ref PlatformMovementComponentData. So let's create a new method, base compile private void reverse movement, int sort key, entity, ref PlatformMovementComponentData, PlatformMovementComponentData. Let's modify PlatformMovementComponentData is reverse movement to the opposite state and set the component via ECB parallel writer. Okay, back to the execute method. Let's assign new position to the local transfer.position. Then set component via ECB parallel writer. That's it. Let's go back to the update function and copy the getEntityCommandBuffer method from another ICE system. Remember to implement missing require for update. Next, we want to run our parallel job, so let's write job handle equals new platform movement job and pass the necessary parameters, it as entity command buffer and delta time. Of course, we'll call schedule parallel and pass the state.dependency. Finally, let's call job handle.complete. Alright, let's go to the Unity editor, wait for the compilation process to finish. First of all, let's create variant prefab based on the ground prefab. Let's call it ground up down movement, and inside it, add a new platform movement authoring component, and let's choose some parameters. As you can see, the positions of the gizmos are updated correctly as I change the parameters. It's time to modify level 1 prefab, so let's select it. Add our newly created prefab, ground up down movement, and position it on the scene. Okay, everything prepared, so let's play the game. As you can see, the platform moves, but the player doesn't snap to it. We'll fix that in the next video. I would like to invite you to support us on the Patreon, where you can get the exclusive code, all models, materials or code used in this series, and access to early available content. Link in the description. Thank you for your time. I'm glad you are with us and our community is growing. See you soon in the next video.